frequency of an element after performing the at most k operations. K operations were increase an element by 1. So I can just add 1 just k times. So basically in total I can increment k. All the numbers in total I can increment by k. So that is what this line infers. Cool. And again it just says that the maximum possible frequency of an element. So basically it just says that if I have an array of size of let's say element 1 2 3 4 5, so 5 has a frequency of 1. So can I make other elements as the 5 itself so that the 5's frequency can increase, right? So that what we want ultimately in this question. If we have this, so we know that okay, we can in total increment the numbers by 5, right? So I can just say, what if I plan to make 4 as everyone, so that I can just plan to increase the frequency of 4. So right now the frequency of 4 is 1, but I plan to increase the frequency of 4, so I plan to make this 2 also of 4. So I'll just increment by 2. So I have used 2 of this, remaining is 3. I plan to increment this 1 by 4, like 2 4. So again I have to add a 3. So again I use the entire 3, I will remain 0, and again I'll make a 4. So you know, like you can see I increased the frequency of 4, and that became the frequency of 4 as 3. So that is ultimately what we want. So now coming on back, that what we wanted, we want the maximum possible frequency. For sure, if we want the maximum possible frequency, we will try to take any of the existing element. Let's say in this question I took a 4. What if I plan to take the existing element as 2 and I plan to make the others as 2 also? So that is one thing. Okay, I'll just plan to take any of the element from the array itself and then just plan to make everyone as same. Now Aryan, why not you plan to make everyone as 3? Okay, if I just say why not to make everyone as 3, for sure if you plan to make everyone as 3, you cannot make a 4 as 3, you can only make a 2 as 3. But I'll ask you, your only task was to make everyone same. If you plan to make everyone as 3, for sure you will make 1 as 3 and 2 as 3, right? Rather I would say make 1 as 2 and 2 as 2, so that you won't actually need to increase the existing element also. Here you would not have to increase 2 itself, but if you plan to make 2 as 3 also, so for sure you will have to make 2 as 3 also, which will actually incur a cost for you, which you don't want, because you want to make as many elements as same as possible. So one thing that okay, we would not be making 3 as the element, or basically we'll only plan to make the element in the existing array. Aryan, why not 5, which means the more element? Again the same concept. For the 2, 3 was the more element. For 4, 3 was the less element. So for sure we will not make more or less elements as the same frequency one. We will just pick these elements from the array itself and try to make them as same. Now okay, this is fun thing that okay, we'll just pick off the element from the array itself and then try to make the other elements same as that of that me element. Now me element can be this. We will see that how we plan to make it, but one thing we have got to know that we will just choose this element itself. Now one thing, if we are allowed to only increase not decrease, so for sure if I plan to make everyone as 5, now I cannot make everyone as 5, I can only make the lesser elements than 5 as 5, right? So if I plan to make everyone as 5, so I can only plan and pick 1 and 3. I cannot touch a 7. So for sure if I plan to make any element as most frequent element, so I'll just plan to make other smaller elements than him as him. So other smaller elements than 5, which are 1 and 3, I'll plan to make them as 5. So for sure kind of an infer of sorting we can think of, that maybe we have to sort, but it is not important to sort, because I'm concerned about only the lower elements. I'm not saying I'll need the next smaller element itself or something like that. So I'm just concerned, okay, maybe just the lower element I need, maybe I can just edit on the array itself, I might not need sorting. That is one intuition which we have got so far. But if we see that we have a k limit given, it is not an infinite k I can just achieve, or I have a limit of k. For sure if I have a 5, so if I want to make everyone as 5, so I'll just try, okay, let's make one other element as 5. Next, okay, let's try to make other element also 5. So for sure if I have a 5, I will firstly try to make a 3 as 5 rather than 1 as a 5, because to make a 3 as a 5 I'll need a cost of 2, to make a 1 as a 5 I'll need a cost of 4. It's much better to actually make one of them, which means 3 as a 5 first, and then whatever remaining I have I'll try to make a less smaller value as a 5 itself. So because I greedily want maximum number of elements to become the same frequency. So with this fact, we know that for sure I will have to go in the order of smaller elements. So for this 5, I just have to go for 3 first to make it actually equal to 5, and then go to 1 to actually make it equal to 5. Thus we get to know that we will have to do a sorting. So for sure, first operation which we have to do is sorting for sure. Now other thing is, let's say again we have to make this number as 5. Now for sure I was going backwards and checking, can I make it? So what will happen if I go backwards instead? Like let's say I'm currently at this pointer. Now pointer, you can just have any P, R, L, I, anything you can have. Like I just named it as R. I'm just okay, I'm just currently at this index. It's just a pointer and I'm trying to go backwards. It is what my task says to me. Now let's say I want to go length backwards because I want the maximum number of elements, or basically maximum length as to become as 5. So I'm just trying to go length backwards. So for sure, if I go length backwards, then what could be my L? What could be my L? Just simply, if L would have been existingly there, so R minus L plus 1 would have been equal to length. So for sure, L would actually become R minus length plus 1. So I just got to know that, okay, if I am at R and I plan to go length backwards, so my L will look something like this. I have got my L. Now what my task is how much length I can go backwards, or basically just saying, okay, how much I can make elements in this length as same frequency. So what I need to achieve, to make everyone as 5. If I want to make everyone as 5, so 5, 5, 5, something like this will happen. Now I got to know that my L is here because I plan to make my length as same. So I know my L is here. So for sure, this length is actually nothing but R minus L plus 1 is the length itself, which we have already known, right? And we also plan to make everyone as 5. So for sure, the sum I need right now, what I want is actually nums of R, which is this value 5, into 3, which is the length, right? Which is the length. So I want this, but it is not what you want, it is what you have. What you have is this sum, already sum. So my sum is right now 1 plus 3 plus 5. So this is the sum from L to R which I have. So which is what I wanted, okay, which is what I have. Now again, is it what I have only sufficient? But there's one thing also I also have a K, which means I can also increase that range sum with some values. So for sure I can just go anywhere and increase, and I know greedily, firstly I will just try to increase this, then whatever remaining is this, I'll increase this, and then go on, so on, so forth. So for sure I also know that I can add a K. So this is what I want, this is what I have. For sure, if what I want is actually less than equal to what I have, for sure I can achieve this and make everyone as 5. What if I have this as more? For sure I cannot achieve it. So I can achieve it only when I have this condition that what I want is less than what I have, for sure. But you saw one thing, that you want to find the sum in this range. Now if I ask you to find, while doing a query, and finding the sum in this range, what you will do, you will use a sliding window. So for sure, firstly we get the intuition of how to use sorting. Now we get the intuition how to use a sliding window. So for sure we get to know, okay, that we will have to apply a sliding window logic to find the sum. The main logic for sliding window is to find the sum. Now okay, to find the sum, that is done, but what I wanted was this length as the maximum length. So while doing a sliding window, while finding the sum, keep on checking this condition right here. And I'll try run, like no worries, I'll try run the entire thing, but the logic is firstly important before dry run, right? So we know how to know that it's a sliding window question. Now when we have known this fact, we will actually want to maximize our length. What we'll just do, simply go and do a sliding window. Whenever we'll get the maximum length, for sure we'll just update our maximum frequency or maximum length as an answer. Now what we'll do is move R. Now sliding window, again sliding window has 2 variations. Simply again remember this fact, sliding window has 2 operations. Make it as a template, because for sure many people just get confused in sliding window. Always keep on moving R, and always keep on moving R. As soon as, okay, you have moved R, you have an L. Now check until this condition. Now condition is what you have. Now, until this condition is not satisfied, how this condition will be not satisfied? When this is more. When this is more, this condition will not be satisfied. Until this condition gets satisfied, keep on moving L. So, until unless, like, while this is happening, keep on moving your L. Keep on moving your L. Keep on moving your L. So that you will finally, whenever this condition gets satisfied, or like this is wrong, which I am saying, while this is true, while this condition is not satisfied, which is when the target is more than what you have, for sure this condition will not be satisfied. So this thing, more, will be true. So while this fact is true, keep on moving your L. As soon as this fact, which is while this condition, becomes false, for sure you will drop out, which means now you have the correct range. So you will have this correct range of L and R, and then you can update your answer. So again, if the condition gets unsatisfied, move L. So for us, this condition was like out condition. So ultimately I'm saying, while this condition is true, keep on moving your L. Keep on moving your L. While this condition is true, keep on moving your L. That is what we want. And for sure, as soon as the condition gets unsatisfied, your loop will break, and for sure you will have the correct L and R range to update your maximum length or the maximum frequency. Ultimately, let's try run. It's pretty simple, but yeah, keep remember this fact, what I told you. Move L and then again, the sliding window has two variations. You move R, for sure, R. Other fact is, in this, there are two variations, which means L shrinks, right? And get to a value when the condition becomes satisfied. Other variation is L will only come one step, because we know that, okay, if this length for sure is 4, I know for sure the max, like the at least length 4 I have, and I only am concerned about the length itself. I know, okay, the value is 4, the length value is 4, and I'm concerned about the length. So if I don't want to decrease the length beyond 4, so I'll just increase my L just once. I'll not like shrink my entire L to the very minimum. I'll just only decrease my length 1, and I'll like next time increase my R. Decrease L, R, decrease L, R, with this fact. But what if I want to have a sum in the range? Then I have to shrink my entire L, because I'm not concerned about the length, I'm concerned about the sum. So this one variation, no worries, I'll just show you in the code itself. But meanwhile, let's see how the sliding window will actually work. For sure, initially you will have, again as said, you will move your R one step. You will see R is here, next time R is here, next time R is here, next time R is here. R will always move one step, for sure. So next, but our L will always start from 0 itself. So L is always starting from 0 itself. Now, for sure is as soon as you land into a loop, you will increase your current R, because you are at this R. Initially your sum was 0. You landed on this R. Add a value of 1 in this R. Cool. Now you have this thus total. It is what you have. Okay. Again, is what you have. What you want. You want this 1, but for the length of 1. So this is what you want. You want a 1, and also you have a 1 plus 5, 6. So what you have is 6, and what you want is 1. For sure it is more, so it is possible. Increase the maximum frequency by 1. Cool. Now go on. Your R has moved for sure. It will for sure move ahead. L was still remaining at the 0 itself. It was still here. L is still here. Now I'll just again check. Now, just no worries. As soon as you moved your R, please make sure to add the corresponding. Earlier, the total was 1. Add the corresponding 4, get the new total. Cool. Now, again, what you have, 5 plus 5, you have a 10. And what you want a 4 into the length. Length is R minus L plus 1. 4 into the length. Length is 2, which is R minus L plus 1. You got a 8. You wanted, like you have a 10, you want a 8, for sure it is true. It is less than equal to, it is true. Cool. So this is satisfied. Again, increase the maximum frequency. Earlier it was 1, now it has become a 2. Again, move ahead with your R. Now, earlier the L was here itself. Now, what I have right now is again, as you move your R, please add 8 in your existing answer, which is 5. So total was 5. Add 8, get a 13. Now you have got a 13 for sure. You have this length. So what you have right now, you have a 13 plus 5, you have a 18. What you want, you want 8 into this length, which is 3, because 8 plus 8 plus 8, you want. You want a 8 into 3, it is actually 24. Bro, I have a 18, I want a 23. It is more, which is, it is not less than equal to. For sure this condition is false, which means you have to increase the R. As I showed you, while this condition is there, which means your wanting is more than what you have, for sure increase your L. So for sure I'll increase my L. Again, I'll go and check what again, as you increase your L, please make sure, bro, to decrease your total also. So before increasing, you had your L here, firstly decrease your total. I'll decrease the total, I'll get to our 12. So now my new total is 12 itself, right? Not 13. Again, I have now increased my L. Again, go and check. Okay, bro, what I have right now is 12 plus 5. I have a 17, but what I want is, bro, I want is 8 into this length, which is 2. I want a 16. I have this 17. It's good. Cool, bro. Just move on. So I'll just update my maximum frequency length. Again, it will become a 2. Again, you will move your R. R will always move ahead in the next step. Again, your L was pointing here itself. If you remember, your L was pointing at 4. Right? So you will just move ahead your R. You will add a 13 to your previous total, which is 12. You will get a 25. It's a new total value or a new sum. Again, what you have is 30. 30 I have. What I want is 13 into this length, which is 3. I want a 13 into 3, 39. Bro, it is more. So increase your L, and again keep on increasing your L until this condition is satisfied. So that is a while loop. Now I'll just increase my L. Okay, bro, I'll just increase my L. Again, as you increase your L, please, bro, make sure to decrease total. It will become 21. Total has become a 21. Again, my new value which I have is 21 plus 5. I have 26. What I want is 13 into this length, which is actually again 26. It's true, for sure. Increase your maximum frequency by 2. So this is how you will go about. Let's quickly code it up, and before that, for sorting it's O of n log n, and for just simple side element it's actually O of n. Again, to sort, we have not used any extra space, but while sorting, Java and C++ takes log n space, while Python takes O of n space. So for sure, just make sure that you actually infer this indirect space which is being used. Cool. Let's quickly see the code. Again, it will be pretty simple as what we saw. I'll show you both the variations, completely string and not string at all. So firstly, as we saw earlier also, that what we want right now is, firstly, have a sort, because I want the order of these elements and I want it to not impact other elements. Now I want the total L, R and stuff, and you will see the total can actually become more than the length limit. So although you can have only total and just cast other variables, but you will see that I actually needed LR, but then multiplying my nums, which is integer, into LR, which is also integer, so it will become an integer, but that can actually go overbound, so I have to cast that up. So rather take everyone as long, no worries in this part. So what I will do is, what I want is maximum frequency or the maximum length. Right now, you see maximum frequency, maximum length for sure can be 1 because of this question itself, length is 1, but let's take it 0 or 1, anything whatsoever you want to take, you will actually get this increase. Now you want an L, you want a R, you want the total also. Currently the total is also a 0. I don't think we want other variables. Oh, we also want an n, which is the length, because I will actually go for this length. So I'll just do a dot size. Now our standard side window approach will be just keep on moving your R. You have initialized your R, so no worries, just get, although if you don't even initialize it, still it will get initialized, but yeah, I just usually have a habit of writing like this. Now you have moved your R forwards. As soon as you have moved your R, just make sure that you add that corresponding value in your total. So I'll just simply add that value, but now we have a task to move your R L. Now again, we have seen that we only will move our L when it is actually, for sure, L we move only when it is less than, which means L plus 1 is less than equal to R, only then, because L and R are, L is behind, R is forward. And again, the main condition was that our target, like what we want is more than what we have. What we want was nums of R into the length, into the length. Length was R minus L plus 1. Now I'll only move when I want, which is more than what I have. What I have is total plus the value of k. Only then I will actually plan to move my L. Now before moving your L, please make sure that you reduce that value from the total. So I'll just reduce that value, and also just simply increase your L. Now when I have got the L and R, correct L and R, just update your maximum frequency, and you can also name it as maximum length, as maximum frequency, and also the value of R minus L plus 1, which is the length of this corresponding. Now ultimately return the maximum frequency. Now it should run, considering we did not do any error. Maximum frequency, okay, R was missing. Now I hope that you guys got it. Now this was that you completely shrunk, and you see while, which means you completely shrunk your L. Now in this question I'm just want the maximum possible range. If I have got the range of 4, I can just continue this range parallelly. I don't need to shrunk this range to 2 and then increase the R again, right? So in this case only when I'm concerned about the length and I'm concerned about the maximum length, which means I'm concerned about the length and I want to increase the length itself. So what I can do, if I have got a length, let's say of 4, so this if condition will make sure that I'm only decreasing it once, and okay, I decrease it once, and next time my R will increase. So for sure my length will only keep on expanding and never will shrink, right? Again, this should also work, and this is another fact which you have to make sure to actually optimize it. Although runtime you will see that it is not much optimized. It will see 173 and 170, not much increase, but in an interview it is very much important to actually showcase that you don't want to actually shrink it entirely and then move on ahead. I hope that you got it. See you in the next video. Bye bye.